So 2.3 is on the algebra of functions. Now, what does that mean? Well, we're going to start working with multiple functions in the same problem. So if you had, 2 or 3 functions together, how can you make them interact? And what's interesting is you can work with functions in the same sort of way you work with numbers. You can do operations on them like add, subtract, multiply, divide, and other things. And so the algebra of functions is just how we do that, some of the details. Okay. So when we work with multiple functions at the same time, we usually give them different names. So instead of using just, f of x for all our functions, that's the most common or standard one, we're going to change it up and use things like g of x or h of x or other things, right? So you might see, any of these expressions for a function. When we start working with actual applications, like story problems, if we were talking about, cost and revenue and profit or something for a business, you might see things like C of X would be the cost, cost to produce X items, or the profit is P of X, right? So that's the profit earned from producing and selling X items. Those sorts of things. So you can use a variety of different variables or letters to represent your function, and you can base it upon what the variables represent. Okay, so if we're talking about in physics, the force of 2 things hitting, you might talk about f of x, right? But it's big F usually when we talk about forces in physics. Okay, so lots of different ways to represent functions. The same sort of structure, but different variables. But generally in this section, in this class, we're just going to stick to these basic ones, F, G, and H. We don't often get more than 3. But sometimes you'll see more than that, so we can do K of X or L of X or whatever. Whatever letters you want to use. So, and then what we can end up doing then is just doing arithmetic with them, or algebra, so adding them, subtracting them, and so forth. So you might see things like F plus G, or I should write it this way, F of X plus G of X, okay, where you're adding the 2 functions together, or you could, again, subtract or multiply or divide, right? So any of those could work. So let me go through, we'll work through a couple examples and I'll kind of show you the steps. It's basic, it's going to end up being a lot of basic algebra type stuff, algebra 1 type stuff, where you're just combining like terms, using the distributive property, the FOIL method to expand things. And so it's not usually going to be stuff you haven't seen before, but the notation can be a little bit tricky. So that's what we're going to work with. And then while we're at it, we're going to go ahead and include a discussion of the domains of those things. We don't usually talk much about ranges in this class outside of some very basic examples. Ranges are much harder to work with, but domains are a little bit more important and easier to deal with. So we'll deal more with domains in this course. And so we'll work with some domains for this stuff too. So let me work through a couple of examples. Get rid of this. And we'll say maybe f of x is equal to 3x plus 2, right? So that's a function, 3x plus 2. And let's say g of x is 5x minus 7. Okay. So there I've got 2 functions. And what I want to do is we'll find their sum, their difference, the product, and the quotient. So we'll find all 4 of those things. Add, subtract, multiply, and divide. So first thing is the function f plus g of x. Now this notation looks a little bit silly because you've got a bunch of different parentheses and things going on here. So inside the first set of parentheses is the operation that you're trying to do, the f plus g. The second set of parentheses represents what the input is. In this case, it's x again. Okay, so we've got f plus g of x. Now, this notation really is nothing different than simply, I'm going to try to color coordinate here, simply f of x plus g of x. Okay, so you're just taking one function, adding it to the other, and that's it. So let's see. So I'm just going to coordinate these. So f of x I have in green. I'm just going to write that function in. I'm going to do a substitution. I'll keep it in parentheses, 3x plus 2, and then a plus. And then g of x is 5x minus 7. I'm going to sneeze here. Okay, little allergy thing going on. Okay, so once I get those substituted in, you can see where they go. Really, all I'm going to do is combine like terms. If I'm adding two linear functions or two polynomials together, I can just combine like terms. So at the end here, 3x, I'll just write this out one more time so that everything is outside of the parentheses. And then we just combine all the x's, combine all the constants, and we'll be done. So 3x plus 5x is 8x. 2 minus 7 is a negative 5. That's all we can do. And so, because there's unlike terms there. So what we're really doing in the end is we're taking two functions and creating a third one by adding them together. Okay, so your final answer is just going to be a sum. It's going to be another combination of two functions. Okay, and then we can repeat the process for subtraction, multiplication, and division. So let's repeat it, and I'm going to have to get rid of this. Actually, what I'm going to do is I'm going to store these answers off to the side for a moment. So I know that f plus g of x is 8x minus 5. Okay, so I'll store that, erase the work, do the next couple. And then we'll come back and talk about all of them together at the end. So now let's find f minus g of x. Again, this notation looks a little silly, but really we're talking about, we've got what the operation is in the parentheses here. The x that's in the parentheses, again, is simply the input. We're not multiplying by an x or anything like that. This is the input for the function f minus g. So again, we take, it's equivalent to the f of x function minus the g of x function. And then we just replace everything accordingly. So f of x is 3x plus 2. G of x is 5x minus 7. And then, of course, with subtraction, you want to do a distributive property so that you can eliminate the parentheses before you can combine terms. So to use the distributive property here, the second set of parentheses will become minus 5x plus 7, right? You change both signs when you subtract. Okay, so once you've done that, then you can combine like terms. So 3x minus 5x is negative 2x, and 2 plus 7 is plus 9. Okay, so negative 2x plus 9. And so that's going to be my difference or my subtraction. F minus g of x is negative 2x plus 9. Okay. What's interesting here is that you're actually finding different functions. So these two things are obviously not going to be the same. Just like when you add and subtract numbers, you don't get the same thing. Okay, let's look at multiplication. So if I do f times g or fg of x, usually with multiplication, we don't put the symbol in between, we just leave it fg. I'm going to have to start moving the cursor around on here so it doesn't fall asleep all the time. Okay, so fg of x. And so with that, we're going to take the function f of x, and we're going to multiply it by the function g of x. Again, I don't use the symbol, the times symbol. We usually just leave it blank, or you could put the dot in there, but I usually tend to leave it blank. You can still leave your text blank. And so, again, I'll color coordinate these. The function f of x, I'm going to put in parentheses 3x plus 2. When you substitute things in, we like to keep things in parentheses. That way we know what operation to do as we work through this. So the g of x is actually going to be 5x minus 7. And so what I'm doing is I'm taking the f function, multiplying by the g function. To do that multiplication, we'd use distributive property, or in this case, the FOIL method, which is sort of a glorified distributive property. And so we do 3x times 5x, which is 15x squared. 3x times negative 7, which is minus 21x. 2 times 5x is 10x. And 2 times negative 7 is negative 14. Again, I'm assuming you guys have done the FOIL method before. We get into chapter 5, we'll kind of build off of that. And I probably won't call it the FOIL method very much longer, because when you get more than 2 terms in those parentheses, then the FOIL letters don't match up right. So, so for now, I'll call it that because you may be familiar with it, but eventually we'll just call it the distributive property. That's really what we're doing. And then the 2 terms in the middle we can add together. That'll be a negative 11x. So I've got 15x squared minus 11x minus 14. And that will be my product. Okay, so I bring this back over here. Fg of x is going to be 15x squared minus 11x minus 14. So what I've done now is I've actually created an x squared term in my function by multiplying it. Okay, so sometimes multiplication will create a new type of function. Okay, so instead of being linear, we have something called a quadratic, which we'll talk about in a later chapter. Okay, and then let's look at the division now. And so with division, we usually write it kind of like a fraction, f over g, or f divided by g, so it looks like a fraction here, f on top, g on the bottom. It doesn't matter. I could do those in the other order too. I could do g over f, as long as the corresponding function goes in the corresponding position. So here I've got f over g. So f is going to go on top, g is going to go on the bottom. If I flip that, if I said g over f, I just got to make sure to put the g on top and the f on the bottom. Again, I'm just doing these alphabetical, f and g, but it doesn't matter. Whatever's listed there is the order you have to put them in. Okay. Same with all the other operations as well. So f over g is going to be 3x plus 2 on top, big fraction, and 5x minus 7 on the bottom. There is no simplification we can do on this one, and even if there was the potential for simplifying, I don't want you to do it with these yet. When we get into, I don't remember what chapter it is, like chapter 6 or something, we'll see more complicated fractions like this that we are going to simplify, but it's beyond where we're at in the course right now. So right now, all I want you to do is write the fractions out and then leave it alone. Don't try to simplify anything, just leave it as is. And that's it. There's nothing else I can do because I don't know. We haven't gotten into simplifying these big fractions yet. We're not going to try. We're just going to leave it alone. So the ratio, or the division, f over g of x is just simply that fraction. That's it. There's nothing else to do. So it's 3x plus 2 over 5x minus 7. Okay. So I've got those four functions. Now again, I could combine them in other ways. I could do g minus f, or I could, do some other combination. I could even do a function with itself. It's kind of an interesting one. So if I wanted to do something like, let me get rid of this, something like f times f of x, and I could do ff. Well, ff, or f times f, is just 3x plus 2 times itself. Okay, so that would be same as f of x times f of x. Oh, I should have done those in green. Right, I'm trying to color coordinate these. Keep it consistent. It bothers me if I don't. F of x, f of x. Okay, and then that would be 3x plus 2 times 3x plus 2. And then I go through and use the FOIL method on this as well, or distributive property. That gives me 9x squared plus 6x plus another 6x plus 4, which is 9x squared plus 12x plus 4. Okay, so again, it just creates a new function. And there's a lot of different ways you could combine these functions. I won't go through all of them, but that gives you some idea. Now let's look for a minute at the domains of these things. There are some functions when you start to combine them. I'm just trying to make sure we cover domains here. Yeah. Okay. So when you start to combine these functions, the domains can be a little bit tricky. In these final answers, let's take a look at these. So if I wanted the domain of, let's do the f plus g for a moment. Domain of f plus g. Well, f plus g is just 8x minus 5. When you're looking for domains, remember domains are all the x values that you can plug into the function. And so you want to think to yourself, when you don't have a graph to look at, think to yourself, what can I not plug into this function? Because most things you're going to be able to plug in. The question is, what can I not plug in? Well, in this function, there's really no number that you can't plug in, right? It's just a number times 8 minus 5. Well, no matter what I plug in, whether it's a decimal or a fraction or a negative or positive or 0 or a big number or a small number, no matter what it is, I can always multiply by 8. That's an easy operation. And I can always subtract by 5. So again, nothing wrong with those things. So here, there's nothing that I cannot plug in. So just as you're thinking through these things, and get rid of that G. I don't know why I didn't do that. As you're thinking through these things, you're thinking, what can I not plug in? So that's the question, right? What can I not plug in? And the answer here is nothing. There's nothing that you cannot plug in. So nothing is the answer to that question, but that means that everything is in the domain. If there's nothing that has to be taken out, then everything is in it. So everything is in the domain. So I'm just kind of writing out the rationale. Your actual answer then is just going to be all real numbers. It's a whole number line, right? So the domain is, and we talked about this in a previous video or in a previous day, negative infinity to infinity. It's the whole number line. Again, you could call this all real numbers. You could utilize the set form, which we just use this capital bold R symbol for it. Either one is fine. It doesn't matter to me. I think my math lab is going to prefer this negative infinity to infinity interval notation. Okay, so that's our domain. The domain for the other functions is going to be similar. For the f minus g, it's going to be similar. It's going to be the same thing, because when you take a number, multiply by -2, and then add 9, there's no issues. There's nothing you can't plug in. Same thing here. Now in this one, you plug in a number twice. In one step, you square it and then multiply by 15. In one, you multiply by 11, and then you do some adding and subtracting. Again, there's no issues with any of those operations. They're all real numbers. Okay. The one that's a little bit weird is the division. Okay, let me do this one in red. The division one here is tricky, and so I'll explain why. I wanted to find the domain of f over g of x. Okay. The problem is there are some numbers, when you're dealing with fractions, there are things that make the fraction undefined. Okay. In order to make a fraction undefined, the denominator, the bottom, has to be equal to 0. Okay. So to make a fraction undefined, the bottom must be 0, okay, or the denominator. I'm not using proper math terminology there, but the denominator must be 0. Right? So anything divided by 0 is undefined. It's the only way to make a fraction undefined. And so the only things you cannot plug in are things that make the bottom 0, right? If you make the bottom 0, the fraction is undefined. Well, what would make this denominator 0? Well, 5x minus 7, it's not real obvious. If it was x minus 3, you would know that the x value would be 3, right? 3 minus 3 is 0. But here, I don't really know offhand because it's a little bit more complicated expression. And so to find that, I just look at the equation 5x minus 7 equals 0. I take the bottom, set it equal to 0, and solve for x. Okay, whatever I get is going to be the number that makes the bottom 0. So to solve this for x, I'm going to add 7 to both sides and divide by 5. Just a basic linear function or linear equation. And I get 7/5. Okay? Well, 7/5, if you want to think of it as a decimal, is 1.4. But x equaling 7/5 would make the bottom 0. So if you plug in 7/5 or 1.4, it doesn't matter, 5 times 1.4 minus 7 is going to be 0. And a 0 on the bottom makes the whole fraction undefined. That we can't have. So our domain, so anything else will work. That's the only number that's going to do that. And so everything else is in the domain except 7/5 or 1.4. Okay? So our domain is all real numbers except 7/5. Okay, it's all real numbers except 7/5. Now, how would I write that as an interval? Because my math lab is not going to like this answer, written out in words. I don't mind it. If it was on a test, I'd probably take it. I would take it. But my math lab doesn't like it. Your textbook is not going to represent it this way. It's going to represent it as an interval or as a set. And so I'll show you both of those. First, the set form. Okay, as a set, write that a little bigger. Handwriting's getting a little sloppy. As a set, I would want to show that it's all values, again, it's a domain, so it's all values of x. And then I need a property on the x. Well, x is going to be everything except 7/5, so it's going to be not equal to 7/5. Okay, so you're going to say x is not equal to 7/5. Okay. Again, you could call that 1 2/5, or you could call it 1.4, however you want to write that, as long as it's equivalent. Okay. But I don't like to convert these. If an improper fraction is fine. So one thing you guys keep in mind, improper fractions are good answers. You never have to convert them. Should I say never? You rarely, if ever, have to convert them to a mixed number or a decimal. I like the improper fraction. It's just less work and less possibilities for mistakes. Okay, so x is not equal to 7/5. Now, the other question then arises, what is the interval form? To get the interval form, it may be easier for you, it may not be. I'm a visual person, so I might draw out a number line, and then that helps me out to determine that. Some of you might be that way and might appreciate that. If not, just hold off to the end. I'm going to show you the number line. Let's say you had a number line. Now, 7/5 is somewhere on the number line. I know that it's 1.4, but whatever it is, it's on there somewhere, right? And it's not included. So I'm going to use an open circle to represent 7/5. Well, everything else is included. So everything to the left is in the domain, and everything to the right is in the domain. So the interval, there's really two different intervals that we're using. We're using the one on the left and the one on the right. So the one on the left starts at -infinity, okay, and goes up to 7/5. So 7/5 is the right endpoint. Of course, -infinity is never included, so I'm going to put a parenthesis there. But neither is the 7/5. We don't want that in the set. So I'm going to put a parenthesis there. The right interval starts at 7/5 and goes to infinity, positive infinity. And so I'm going to write those endpoints, so 7/5, comma, infinity. And again, the infinity is not given is not in the set, so it's given a parenthesis. And the 7/5 also, I don't want it in the set, so it's given a parenthesis. Now, when we want an answer to include more than one interval, we use a notation called a union. It's a U, so it's a U shape, and it represents the union of two sets. Essentially, it kind of combines everything from one set and everything from the other set into a single set. So we're going to use a U symbol representing the union of two sets. So I've got interval 1, union interval 2. Notice that every possible real number is in either the interval on the left or the interval on the right, except 7/5. It's the only thing that's not included in either of those intervals. I believe, don't quote me 100% on this one, but I believe typically the interval form is what my math lab wants. Okay, so they do get kind of lengthy to write out, and what's even worse is when you have multiple intervals. I'm sorry, more than two, multiple numbers to exclude. Maybe I'll give you a quick example where that might happen. So let's say, let's take two colors again. I'll use f of x equals 2 over x minus 7, g of x is x over x plus 2. And maybe I want to find, now I could do a bunch of things here. I could again find f plus g, f minus g, g divided by f, all these different things. When you have multiple fractions like this, we're not going to do too much with simplifying. Okay. Again, in chapter 6, we're going to see more simplifying of these things and combining and getting like common denominators and combining them. Not going to do that right now. It's too much for what we're talking about. Oh, I didn't save the computer there. Fell asleep on me. There. Okay. Almost got it. Okay, so in this example, maybe we'll just find the domain of their sum. So the domain of f of x plus g of x. Well, first of all, I have to find that function, but it's not real hard because I'm not going to combine things. F of x plus g of x, or f plus g of x, is simply 2 over x minus 7 plus x over x plus 2. Again, I'm not going to simplify it. It looks ugly, it's long, it's big, but that doesn't matter. We're just going to leave it alone. What we do need to know is that the domain of a function is includes the domain of its parts. So like, it's the intersection of the domain of its parts. So you've got two different functions added together. So you take the domain of one, the domain of the other, whatever's excluded from either one is going to be excluded from the final answer. So it's an intersection. It has to be, so points have to be in both the domain of g, of f and of g in order to be in the domain of their final sum. And so, so you want to look at, again, these are fractions, so what makes the denominator 0? Well, in the first one, what makes x minus 7 equal to 0? Well, if you add the 7 to both sides, you find out that 7 makes the denominator 0. So like if you plug in a 7, you get 2 over 0, which is undefined. On the second one, you take x plus 2 equal to 0, subtract the 2, and you get negative 2. So if you plug in negative 2, you get negative 2 over 0, which is undefined. So either of these two numbers, when plugged in, if you plug in a 7, you would plug it into the whole thing. You would get 2 over 0 plus 7 over 9. And of course, as soon as you have a 0 on the bottom, the whole thing is undefined. You can't add something to an undefined value. So as soon as there's something undefined, the whole thing is undefined. Same thing with the negative 2. The second fraction will be undefined. The first one won't, but it won't matter. And so there's two numbers I want to exclude. So again, 3 different ways to write the answer. I will take all 3 of them on a test. My math lab is, I think, preferring the interval form. Okay, so I'll write all 3 of them up. I'll put them over on the side here. So the domain is all real numbers except 7 and negative 2. Okay, so that's how you would write it out in words. In set form, I would write it out as all values of x. Again, it's domain, so it's x, not y, such that x is not equal to 7 and x is not equal to negative 2. I believe my math lab, if it does want set form, it's going to like it written out kind of long like that, rather than just like 7 comma negative 2 or something. But just make sure, if my math lab does want the set, make sure to pay attention to how it wants you to structure that. And then, of course, the interval form. Well, the interval form pulls these two numbers out. And again, I like to visualize it with a number line first, and then write the intervals from that. That's my personal preference. So I'm just going to show you real quick how that would look. Again, 7 and negative 2, if I put them on a number line, negative 2 comes first. So negative 2 is on the left, 7 is on the right. I'm going to leave those as open circles. I don't want to shade them in. Okay. So negative 2 on the left, 7 is on the right. we shade in all the other stuff, everything left of -2, everything between the two numbers, and everything to the right of 7. So when there are two numbers to exclude, that creates 3 intervals. Right? The first interval is from negative, I'm going to need a little more space. On the left here is from -infinity up to -2, but again, not including that endpoint. The middle interval goes from -2 to 7, again, not including either endpoint. So -2 to 7. The final interval goes from 7 to infinity. Right? So we go 7 and infinity. And then, again, our union symbol goes in between those two, or those 3 intervals, because we're taking the union of all 3 of them. Okay, so I have a union symbol, That gives me a final set containing 3 intervals that exclude 2 numbers. Right? -2 and 7 are the only things not included in that set. Whew, that was a lot of talking. Too much talking for me, probably. I think that covers everything I wanted to hit. Oh, there is one other thing that I should probably mention. You can also evaluate, you could plug in numbers to these, which I didn't really show you, but it's not any different than what we did in previous sections. Show you what I mean. Okay, so I can plug numbers into these functions after I've done the operation. So if you had 2 functions like, just do f of x is -x plus 3, and let's make g of x x squared minus 1, a little bit different, then I could find something like, well, I don't know, maybe we do g, no, that's not even a g, that's an f. Let's do g minus f of 4. G minus f of 4. So the 4 here represents the input. Now there's actually 2 ways to approach this problem. You can create the function g minus f and then plug the 4 in. Or you can plug the 4 into f, into g, and then subtract the answers. There's 2 ways to approach it. You'll get the same result either way. And I'll show you both of them. Okay, so the first one is you create the function g minus f of x, and then plug the 4 in after. So let's do that first. So g is, and I'm not going to color coordinate right now, I'm just going to run through this a little bit quicker. G minus f is going to be x squared minus 1 minus -x plus 3. Lots of negatives here to keep track of. Okay, so I've got my g function first, my subtraction, and then my f function. When I subtract, I want to distribute that to both terms on the right. So I'm going to get x squared minus 1, double negative there is plus x, and then a minus 3. I can combine like terms. I've got a minus 1 and minus 3. That gives me x squared plus x minus 4. And then I can plug in this 4. Right? So now I'm going to do a little color coordinating. I'm going to plug the 4 in. We'll put that in red. So g minus f of 4 is simply 4 squared plus 4 minus 4. Oh, that's kind of interesting. Okay, so notice how each of the x's becomes a 4. I threw parentheses around it just so you could see where that gets plugged in. And then we just evaluate. So that's 16 plus 4 minus 4, be 20 minus 4, which is 16. Okay, so 16 is final answer there. Now, if I were to go about that the other method is just plugging the 4 in initially and then subtracting at the end. I might actually have room to do this over on the side here. Or I'll go off the screen a little bit. So if I did, so since g is listed first, I'll do that one first. So g of 4 is simply 4 squared minus 1, or 16 minus 1, which is 15. Figure out a way to not let that fall asleep. Okay, so g of 4 is 15. Then I could do f of 4. F of 4 is going to be negative 4 plus 3. Well, negative 4 plus 3 is negative 1. And then I do the subtraction, right? I do g minus f. So g of 4 minus f of 4 is actually going to be 15. That's the g of 4. Minus negative 1. That's the f of 4. Okay, so 15 minus negative 1. Well, 15, the double negative makes it a plus, right? So it's really 15 plus 4, or plus 1, which gives me 16. And notice that answer matches the answer we had before. So again, 2 different methods to finding the same answer. You will, if you do it properly, you will get the same result either way. So personally, it does not matter to me which method you use. If you want to create the function first and then plug the n number in, that's fine. If you want to just plug the number in first and then do the arithmetic after that, that's fine as well. I would say this, that generally speaking, if you just have 1 or 2 of these to do, plugging the number in first and doing the arithmetic after is usually faster. However, if you have multiple of these to do, if you have 5 or 6 for the same function, you need to find the inputs, it's going to be faster to find the function once and then just input each one in after that. Okay, so if you have a bulk of them to do, I would probably go through this method, even though it takes longer initially, usually. It'll save you time in the long run. But if you're only doing 1 or 2 of these, I would probably stick to this one. Just saves you some time. But again, they're interchangeable. It doesn't really matter which one you use.